Okay, today we're going to be discussing the nature of the roots. And nature of the roots just means what are they like. Roots are where the graph hits the x-axis. So what happens? What are some interesting things, according to mathematicians, I guess? What's interesting about those spots? So when it hits the x-axis here, there's only one root. Only one root right there. Okay, and it bounces right off. And it's a nice whole number like -1. Over here, going to this one, when you look at this one, I know your graph is a little foggy or unfocused. So when you look at this one, it hits at -1 and -5. Nice spots, but there's two roots, and these are nice, we call them rational numbers. This one over here doesn't hit at all. Okay, this doesn't hit the x-axis at all. So you can hopefully guess if they don't actually hit the x-axis, the roots are imaginary. That's what we've been finding. It makes kind of sense. They don't don't exist, but they do exist in the imaginary world. And this one here is an example where it hits kind of off center. We're not really sure where they are. So there's two roots here, but we call them irrational because, you can't really get an exact answer there. So these are all the possibilities that you can have when you have a quadratic equation here. You could have one, two nice ones, two messy ones, or none. In this case, they'd be imaginary. So what part of the quadratic formula determines that? So when we find the roots, you can find the roots with the quadratic formula every time. Something is irrational if it's a square root. So this part right here is called the discriminant. And you can see it on your reference sheet. The discriminant determines the nature of the roots. So today we're going to be not having this part of the quadratic formula. We're just going to be dealing with this part. No radical or anything. Though you have to understand that it's actually there. Okay, nice enough. This is here. But it is on your reference sheet. You do not have to memorize this particular one. But if the discriminant, so let's say this number I get is negative, so less than 0, so that means negative. The nature of the roots means it's imaginary. And that does make sense, hopefully, to you, because you get I don't know if I spelled that right. Numbers, you get an I if the thing under the radical is negative. Okay, if this thing is equal to 0, meaning the thing underneath the radical is equal to 0, you only get one root, and it's a nice root. We call it rational. Okay, this is the one where we have two roots. So both of these, we always get two roots. And this is when it's greater than 0 or positive. You get two roots. But the difference is if that number is a perfect square. So remember, our perfect squares are 1, 4, 9, 16. If that number is this, then it is considered a rational number. And not a perfect square, we get two roots that are irrational, meaning the radical probably definitely stays there, and we get some crazy number that can't be simplified. So how do we do this? Okay, we take the same A, B, and C that we always did. Y is 0, so these are in order. So A is 1, B is 4, C is 2. And we simply plug it into the b squared minus 4ac. We don't need the whole quadratic formula, we just need a piece of it. So b squared minus 4ac. So this is 16 minus 8, so this is 8. We look at it, it's positive. So you have that piece of paper right in front of you. It's positive and not a perfect square. So what that means is, it has two roots. or sometimes we call them unequal roots, and they're irrational. You just look at your sheet of paper, depending on what that number is, that's what you do. Okay, so this one, A is 1, so this is 0, B is -3, C is 10, so we just do B squared. I'll do that B squared, that's 9, minus 4A, C. So that's 9 minus 40, so that's -31. Well, that's negative, so it's imaginary, meaning it's not going to hit the x-axis at all. Okay, and then finally, A for this one is 0, A is 1, B is -2, C is 1, B squared, remember B squared is positive, minus 4A, C. I do the math, I get 4 minus 4, that's 0. So this one is real, I'm sorry, or rational, and it's one root. You can also say the roots are equal, that there's 2 of them, but they're the same. Okay, so we'll do that a little bit more, and hopefully you'll understand it better.